Okay, 15.1 is two-way frequency tables. So a two-way frequency table allows you to see the relationship among two or more pairs of variables in real-world situations. So this is a two-way frequency table. So we have automobile gas mileage and commute distance. We're comparing mileage with commute distance. Notice that the total value is shown for each column or row, and that the total at the far right of the column at the bottom in the row are the same, which is 50. So that means that there were 50 total commuters that were surveyed. So we're looking for an association. The table can show whether there is a relationship between commuting distance and gas mileage. So looking at our 3-mile commute and our mileage, what fraction of the commuters drove 3 miles and got 20 miles per gallon? So 3 miles, 20 miles per gallon is going to be a total for who drove 3 miles is going to be 21 from your table. The number of those with mileage greater than 20 miles per gallon is going to be 3. So our fraction is going to be part out of a whole, so 3 out of the 21. Or if you made it a percentage, you take 3 divided by 21, which is 14%. Now looking at the 30-mile commute and mileage, what fraction of, I'll erase these. So now we're looking at 30-mile commute along with, we're going to do greater than 30 or 20 miles per gallon too. So what fraction of the commute drove 30 miles and got 20 miles per gallon or more? So the number who drove 30 miles is going to be a total of 29. And those of the 30-mile commute who got greater than 20 miles per gallon is 24. So your fraction, again, is part out of whole, 24 out of 29, which is 24 divided by 29 is 83%. Okay, it says to use the table above to answer the questions. So what association exists between commuters who drove 3 miles and commuters who got less than 20 miles per gallon? And then use the data in your answer. So we need to look at 3 miles and less than 20 miles per gallon. So we've got 18 out of the total, which is 23, or 78%. So that tells us that's pretty high, right? It's more than 50%. So it suggests that there's association between short commuting distance and poor gas mileage. So if you're not driving as far, you probably are not going to get as good as gas mileage. So I'm going to say it suggests an association between short commuting distances and poor gas mileage. So you're going to be reading these and seeing like patterns and trends that you see in the table and in the data. So on the next one, it says, what association exists between commuters who drove 30 miles and got less than 20 miles per gallon? So now we're looking at those who drove 30, right? Oops. And got less than 20 miles per gallon. So that's going to be 5, right? 5 out of the total, which is 23. Or that would be about 22%. So that's telling me that if you're getting less than 20 miles per gallon, that's not an association, but you would then associate, if you're going 30 miles, a long commute, you would get better gas mileage. So that suggests an association between longer commuting distances and better gas mileage. The last question says, what other factors besides gas mileage should be considered when making an analysis of costs of commuting 3 miles and 30 miles? Okay, so there's many different things you can talk about. Well, first of all, you might not be driving the same vehicle, right? So maybe I'm driving a pickup and someone else is driving a car. So you'd have to know what kind of vehicle you're driving. The commute itself doesn't determine gas mileage. A pickup's probably going to get less gas mileage than a car, right? Maybe the engine efficiency. And if I'm trying to save money with my commute, it's the longer I commute, the more fuel I'm going to use too. Even if I'm getting better gas mileage, driving longer and going further in the long run is going to cost more. So maybe I should say a longer commute takes more time, which could use more fuel. Longer commute, even though you're getting better mileage, takes more time. In turn, could use more fuel. Even though it's better mileage, you could still be using more fuel. Okay, let's go ahead and do your guided practice, which is going to be on page 454. So go ahead and turn there, please. Okay, question 1 says, in a survey of 50 students, 60% said they have a cat. Of the students who have a cat, 70% also have a dog. Of the students who do not have a cat, 75% have a dog. Complete the two-way table. Well, we know we have a total of 50 students. Okay, so now we need to use the information. 60% say they have a cat. Okay, so a cat needs to be 60% of 50, right? And 60% of 50 is 30. So 30 people, the total would be have a cat. Of the students who have a cat, 70% also have a dog. Okay, so I need to find 70% of 30. So again, you can use your calculator. 70% of 30 is going to give you a total of 21. And those are people who also have a dog. So if 21 have a dog, and there's a total of 30, that would leave 9 for no dog. You would take 30 minus 21. So you can use the information here to fill out the whole table. Now it says of the students who do not have a cat, 75% have a dog. Okay? So the students who do not have a cat, 75% have a dog. So I'm going to find 70%. So if 30 had a cat, how many would have to not have a cat to get a total of 50? Well, this would have to be 20, right? So 75% of 20, again, go ahead and use your calculator. That should give you 15. So that was have a dog. So that would leave only 5 for no dog to get a total of 20. Now we just add these up. 21 and 15 gives us 36 have a dog, and 9 plus 5 tell us 14 have no dog. So you're using your percent of a number to help you find that information. Question A says, enter the total number of students surveyed at the bottom right. We did that, and then we filled in all the columns, so we have all that done. Okay, question 2, the results of a survey at a school are shown. There is an association between being a boy and being left-handed. Explain. So we're going to see if there's any association that boys are left-handed. Okay, so if we look left-handed, right, and boys is 14. 24 people are left-handed. So 24 out of the total of 240 are left-handed. So if we find that percentage of 24 to 40, that's 10%. So let's find the probability of being left-handed in a boy. So 14 out of 140, which is also 10%. So is there association between being a boy and left-handed? Well, no, there's no more likely of being a boy or a girl and being left-handed. So I'm going to say no. The relative frequency, which was 24 to 40 or 10%, and 14 out of 140, those are our relative frequencies. Of being left-handed and being left-handed and a boy are both 10%. And then the last question says, should have put percent here, sorry. Voters were polled to see whether they supported Smith or Jones. Can you construct a two-way table of the results? Why or why not? Okay, so we don't have any data there, right? We just Smith or Jones. So no. We want to see if we're supporting Smith or Jones, so there's only one variable. The poll only has data for one variable. A two-way table has to have both. So a two-way table needs two variables.